महागणाधिपतये नमः. Good morning. Good morning. I think both the students are joining now. Both sections A, 10A, B. Yeah. Good morning. Good morning. Good morning, children. Okay, I think you are all celebrated this Ganesh Chaturthi very well. Yeah, 10th B students whoever are there, please put a message in your group that the class has started, everyone has to join immediately. Good morning, nation. Okay, I'm starting the class. Okay. See, 10th year children they know, but 10th B children, whenever a question is asked to you, immediately you have to answer by typing through message. Just you can type the answer through message. Okay. Now, there is a problem on the board. See, there is a problem. AOB is the diameter. AOB is the diameter, and two tangents are drawn at the endpoints of the diameter. Two tangents are drawn at the endpoints of the diameter. Okay. And we need to prove that those two tangents are parallel. What is required to prove? L parallel to M. L parallel to M. We need to prove that. And what is given? What is given? AOB is diameter. And two tangents are drawn at the endpoints of the diameter. That is what given. Two tangents are drawn at the endpoint of the diameter. We need to prove those two tangents are parallel to each other. We need to prove two tangents are parallel to each other. I didn't find this Niharika or Moksha or what we call it as, what is her name? Daksha, no. Moksha Vankaya, yeah, okay. Moksha, kindly take the attendance of your class and show it to me tomorrow morning. At the end of the class, not now, at the end of the class, and try to observe whoever leaving from the class, and that one also note it down. Whoever leaving from the class, note it down, and at the end take the attendance and show it to me tomorrow in the class. Right. AOB is the diameter, and we need to prove tangents drawn at the endpoints of the diameter are parallel to each other. Okay. Now, proof. Children, can any one of you say that what are the possible ways that we can prove two lines are parallel? What are the ways that we can prove two lines are parallel to each other? There are different ways that we can prove that two lines are parallel to each other. Can anyone suggest one? Anyone? Yeah, interior angles are equal, alternate interior angles are equal, we can prove. Corresponding angles are equal, we can prove. Euclid fifth postulate. Euclid's fifth postulate, that what we have seen in class 9. Euclid's fifth postulate. What the Euclid's fifth postulate says? If a line intersecting if a line intersecting two lines and interior angles on the same side of the transversal is 180, if sum of these two angles means interior angles on the same side of the transversal is 180, then we can say that the lines are parallel to each other. The lines are parallel to each other. This is what we call Euclid's fifth postulate. Okay, na? So there are three ways. One is Euclid's fifth postulate. Second one is alternate angles are equal. If we prove that angles, the lines are parallel. And third one, corresponding angles are equal, the lines are parallel. Three ways are there. Okay. We can use one of these three ways so that the lines becomes parallel. Now, observe here, AOB is the diameter, AOB is the diameter and OA is the radius, OA radius, and M is tangent at A, OA is radius, M is tangent at A, okay na? And we know that radius is perpendicular to the tangent at their point of contact. Radius is perpendicular to the tangent at their point of contact. That means this angle is 90 degrees. First theorem. First theorem is there na? Radius is perpendicular to the tangent at their point of contact. Okay. Now, OB is also radius. OB is also radius and L is tangent at B. L is tangent at B. Yeah, by same theorem we can prove that we can know that this angle is also 90. Okay. Radius is perpendicular to the tangent at their point of contact. Now children see, sum of these two angles, if we observe, is 180. Sum of these two angles is 180. As I told you before, interior angles on the same side of the transversal, interior angles on the same side of the transversal, if they are supplementary, means if their sum is 180, then the lines are parallel. So clearly here line M and line L are parallel to each other by Euclid's fifth postulate. Okay na? Next question. Next question. Prove that perpendicular at the point of contact to the tangent to a circle passes through the center of the circle. This is very important question. It was asked many times in board exams. See, there is a circle and there is a tangent. A circle with center O. And L is the tangent at P. L is the tangent to the circle at P. Okay. And O is the center of the circle. Okay. Now, what he is asking? If we draw a perpendicular at P, if we draw a perpendicular at P, okay, it passes through the center of the circle. If we draw a perpendicular at P, means a perpendicular is drawn at P, okay, we need to prove that it passes through the center. It passes through the center. Children, what we will do is, we'll try to prove this problem by the method of contradiction. We'll try to prove this problem by the method of contradiction. So I already told you in the class, method of contradiction means whatever he asks you to prove, we'll take it oppositely, quite opposite of it. We'll consider quite opposite of it, and we'll travel for some time in the problem, and after some time we may know that what we are doing is wrong. What we are doing is wrong, and we can come to know that whatever he says is right. Okay, na? So this is what we call method of contradiction. Okay. Now what is asking? The perpendicular drawn at the point of contact, the perpendicular that is drawn at the point of contact passes through the center. Prove that it passes through the center. So what we will do? Let QP is a perpendicular at P. QP is perpendicular at P. Okay. At P. QP is perpendicular at P, but not passing through O. Not passing through O. We'll do like that. We'll consider like that. Let QP is perpendicular to P, is perpendicular at P, not passing through center. Okay. I will consider one more point here, R on the line. I will consider one more point, R on the line L. Okay. Okay. Now, proof. Angle QPR is 90 degrees. Angle QPR is 90 degrees because we have drawn a perpendicular at P. QP is the perpendicular that is drawn at P but not passing through center. Okay, na? Now, construction. I will do some construction. What is it? Join OP. What I will do? Join OP. Join OP. Now, children, can anyone say what is angle OPR? What is angle OPR? What is angle OPR? Can anyone say? And you may say the reason also. You can say the reason also. OPR is 90. What is the reason? What is the reason? Right. Radius. OP is radius. OP is radius. And radius is perpendicular to the tangent at their point of contact. Okay, na? This is 90. Okay. Radius is perpendicular to L at P. This is the reason. Okay. Now from these two, can I write QPR is equal to angle OPR? Can I write like that? QPR equal to angle OPR. Okay. Now, if you observe in the figure, if you observe QPR, angle QPR is greater than angle OPR. It is greater than angle OPR if you observe in the figure. Okay. Or you can say one more statement also. QPR perpendicular to L at P and OPR is perpendicular to L at P only. So we cannot draw two different perpendiculars at same point. That is also one important statement that you can give. QP is a perpendicular at P to line L. OP is also perpendicular at P to line L. Okay. So that means we can see here two different perpendiculars at the same point, which is not possible, it possible only when both QP and OP coincides each other. It is possible only when QP and OP both coincides each other. Okay na? That means the perpendicular that is drawn at P must passes through the center of the circle. That is, the perpendicular drawn at P at the point of contact must passes through the center of the circle. Okay children, once again, here angle QPR 90 according to the construction, angle OPR is also 90, radius is perpendicular to the tangent at that point of contact. So from these two statements we will get this statement: both the angles are equal. This is possible only when both QP and OP coincides each other. Why we cannot draw two different perpendiculars at same point? So they must coincide each other. That means, what is our conclusion? Radius means, if we draw a perpendicular at the point of contact, it should passes through center. It must passes through the center of the circle. Okay na children? Next. Okay, next question. I think 6 and 7 questions, they are very easy, that you can solve them on your own. 6th and 7th questions I am leaving. I'm trying to explain you 8th question. A quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD is equal to AD plus BC. See, children, there is a quadrilateral and it circumscribes a circle. Okay, A, B, C, D. Okay, P, Q, R, S. ABCD is a quadrilateral which circumscribes a circle with center O. Now, children, you can observe here, AB is tangent to the circle at P. BC is tangent to the circle at Q. CD is tangent to the circle at R. And AD is tangent to the circle at S. This is what we have to observe in this problem. See, all the four sides of the quadrilateral are tangents to the circle at P, Q, R, S respectively. Okay? Now, what we have to prove? AB plus CD is equal to AD plus BC. AB plus CD is equal to AD plus BC. Now, children, observe these two sides, AB and CD. AB plus CD. What we call these two sides? What we call AB and CD? Anyone? Tangents, okay. What else? Yes, very good, Moksha. Opposite sides of quadrilateral. Opposite sides of quadrilateral ABCD. And even AD and BC also. AD and BC also opposite sides of quadrilateral ABC. So what is the conclusion that when a quadrilateral circumscribes a circle, when it circumscribes a circle, some of the opposite sides are equal. That is what we have to prove. When a quadrilateral circumscribes a circle, we need to prove some of the opposite sides are equal. Okay, na? Now, proof. Now, children, observe these two. AP, AS. What we call them? AP, AS. What we call them? AP, AS. No, not tangents. Not tangents. They are not tangent. AB is tangent at P. What is AP? What is AP? I told you clearly. Length of tangents. Very good. Length of tangents drawn from an external point of circle are equal. So AP is equal to AS. Lengths of tangents drawn from an external point of a circle are equal. So AP equal to AS. Okay. Now, what about here? BP, BQ. In the same way, BP is equal to BQ. Same reason. BP is equal to BQ. Same reason. And CR is equal to CQ. CR is equal to CQ. Same reason. In the same way, DR is equal to DS. DR is equal to DS. Same reason. Lengths of the tangents drawn from an external point of a circle are equal. Now what you will do? Add LHS and RHS. AP plus BP plus CR plus DR is equal to AS plus BQ plus CQ plus DS. Okay. Now I am rearranging the terms. AP plus BP, and here I am rearranging the terms. What I will do? I will bring this DS plus BQ plus CQ, and I will put them in the brackets like that. Just rearrangement only. Okay? Rearrangement. Now, observe what is AP plus BP. AP plus BP. AP plus BP is AB plus CR plus DR CD. AS plus DS. AS plus DS AD. BQ plus CQ BC. Done. Lengths of tangents drawn from an external point of a circle are equal. They are equal. Okay, na? Lengths of tangents drawn from an external point of a circle are equal. Using that theorem, using that second theorem, we have proved this problem. So with this, what we can conclude? What we can conclude? When a quadrilateral circumscribes a circle, then sum of opposite sides are equal. Then sum of its opposite sides are equal. Okay? Next question. Next question. There is a circle. Sorry. there is a circle with center O and two parallel tangents. Two tangents which are parallel to each other, x y, x dash y dash, and POQ is the diameter. Okay, and AB is another tangent. Intersections at C. AB is another tangent at C. And what we have to prove? What we have to prove? Angle PCQ is 90 degrees. Angle PCQ. Not PCQ, AOB, sorry. AOB, sorry. We need to prove, this is another problem. Here in this problem, what we have to prove? We have to prove angle AOB. Angle AOB is 90 degrees. Okay, na? Now, how to prove this? What is given? What is given? XY parallel to x dash, y dash. POQ is diameter. AB is tangent at C. AB is tangent to the circle at C. Okay. Here lines x and xy and x dash y dash, they are also okay, na? They are parallel tangents. Now, what we have to prove? Angle AOB is 90 degrees. Okay. Now, children, I need to do some construction over here. What is that? I try to join OC. Okay. Now, children, see this setup. What can you say? APOC. See that part only, children. APOC. See that part. APOC. See that part only. Then what can you say about these two angles? What can you say about those two angles, the dotted ones? Okay? APOC. Okay, right? What can you say about the dotted angles? They are equal. So, can I say these two are A and A? Why those two angles are equal? Triangle OPA is congruent to triangle OCA. Triangle OPA is congruent to triangle OCA. Okay. CPCT, angle POA equal to angle COA. Okay, na? Now, you can observe this one also. BQOC. See that part? BQOC. Same. Triangle BQO, BCO are congruent. Triangle BQO, BCO are congruent. Okay. CPCT, these two angles are equal. I am not writing all those because the board is not sufficient. I am not writing it, but you can observe. Theorem 2. By theorem 2 we are doing that one. Is that right? Triangle BQO, BCO are congruent. They are congruent. Okay. So these two angles are equal by CP, CT. Now, children, you tell me what is angle POQ? What is angle POQ and tell the reason also. What is angle POQ and tell the reason. What is angle POQ and tell the reason. 180 linear pair. Pair ante evitra? Pair ante eviti? Evarana cheppandi naaku Shyam. Tell me what is the meaning of pair? What is the meaning of pair, Shyam? Two angles unnaya ikkada? No na? Yes. POQ is the diameter na? Straight angle, you can say angle POQ 180 straight angle. That's all. Angle POQ is 180 straight angle. Yeah. So POQ is nothing but 2A plus 2B is 180. 2 into A plus B 180. A plus B 90. And A plus B is nothing but angle AOB. Angle AOB 90. Is that right, children? AOB 90. But children, whenever you are writing proof for this, you need to prove these two triangles are congruent. CP, CT, these two angles are equal. And these two triangles are congruent. CP, CT, these two angles are equal. That is what you have to write. Okay, na? But I am not writing that one because place constraint, board not sufficient to write all the proof. Okay? Right. Next question. Next question. Prove that angle between two tangents drawn from an external point of a circle is supplementary to the angle subtended by the line segment joining the point of contacts at the center. First try to understand the question. Prove that the angle between the two tangents. So just I need to draw a circle with center O. Okay. PA and PB are two tangents. PA and PB are two tangents. So angle between the tangents means this one. Required to prove, right? Required to prove. Angle between the tangents means this one. Angle APB plus. What else he says? Prove that angle between the two tangents drawn from an external point to the circle is supplementary. Supplementary means 180. That means APB plus something is equal to 180. That is what we have to prove. APB, angle APB plus something. What is something over there? Supplementary to the angle subtended by the line segment joining the point of contacts. Line segment joining the point of contacts. So this is point of A, point of contact B. So join them. Okay. I am joining that. So the line segment joining the point of contacts is AB. The line segment joining the point of contacts is AB. So the line segment joining the angle subtended by the line segment joining the point of contacts at the center means whatever the angle subtended by AB at the center, this angle. We need to prove sum of those two angles is 180. See, it's the statement you have to understand first. If you are not able to understand the statement, you cannot prove it. Okay, na? So what is this angle? Angle between the tangents. angle between the tangents drawn from the external point of a circle. Then what is this angle? Angle subtended by the line segment joining the point of contacts. Angle subtended by the line segment. What is the line segment? Joining the point of contacts? AB. So, what is the angle subtended by AB at center? AOB. Okay na? So, we need to prove angle ABB and angle plus angle AOB is 180. That is what he is asking. Okay? Now, proof. Children, can you tell me what is OAP and angle OBP and the reason? What is angle OAP and angle OBP? What is that? And the reasons? 90. Why? Why 90? Okay, 90. Okay. What is the reason? What is the reason? Yes, radius is perpendicular to the tangent at the point of contact. Now tell me angle OAP plus angle APB plus angle PBO plus angle AOB. How much? Angle OAP plus angle APB plus angle PBO plus angle AOB. How much? 360. Very good. Why? What is the reason? Why 360? Why 360 degrees? Reason? Yes. Quadrilateral 360. Interior angles of a quadrilateral. Sum of interior angles of a quadrilateral is 360. Okay na? Because OAPB is a quadrilateral. Okay. Now substitute angle OAP 90 plus APB plus 90 plus AOB 360. Now APB plus AOB is equal to 360 minus 180, which is 180 degrees. Which is 180 degrees. Okay na? Okay. So the angle between the tangents and angle subtended by the line segment joining the point of contacts at the center, they are supplementary. Means their sum is 180 degrees. Okay children, only 3 sums left that we will see tomorrow morning in the class. Okay. Okay. Now everyone, Tejal take the attendance and Moksha will also take the attendance. So if you like this class, click on the like button children. Click on the like button if you want. Okay. Wait for some time. When I will say leave, then only leave. When I will say leave, then only leave. Tejal and Niharika, not Niharika, Moksha, take the attendance. And show it to me tomorrow. Children, click on the like button. Tejal done. 70 students are joined, only 42 likes. Okay, Tejal done. What about Moksha? अरे 50 likes को 46 है नहीं रहा 50 అవని बन रहा click on the like button ఇప్పుడు 50 likes రాలేదురా నాకు Okay, okay. Thank you very much. Dhanyavad. You can leave now. Thank you.